We'll try set A first. In set A, we'll make two columns. I'm going to use method 2 because I think it's a little bit easier. We'll have a column for x and another column for x squared. We'll put our values 2, 3, 3, 17, 31, 31, 32. We're going to square each of these values. 2 squared is 4, 3 squared is 9, 3 squared is 9, 17 squared is 289, 31 squared is 961, 31 squared is 961 again, 32 squared is 1024. We'll now add the two columns, and the total is 119 for the first column, and the total for the second column is 3,257. Now let's plug it into the formula. Remember, the standard deviation S is equal to the square root of the summation of x squared minus the summation of x quantity squared divided by n, and that is divided by n minus 1. So we can plug in the values. Remember, the summation of x squared is going to be the total of the second column, the total of the x squared column, and this will be 3,257. So we'll plug that number in, 3,257 minus the summation of x, which is our total for the first column, and that's 119. We'll square that, divide by our sample size, which in this case is 7. Our sample size is 7, and we're going to divide that by 7 minus 1. So S is equal now to the square root of 1, 2, 3, 4 divided by 6, and this simplifies to a standard deviation of 14.3. So we have the standard deviation is 14.3. What that means is, on average, we have a difference about 14.3 away from the average. The standard deviation is the average deviation from average. Deviation means to differ. The standard deviation is the average difference from average. Now let's do the same process for set B. We'll enter our numbers for the first column: 2, 16, 16, 17, 18, 18, and 32. For the second column, we'll square the values. 2 squared is 4, 16 squared is 256, 17 squared is 289, 18 squared is 324, and 32 squared is 1024. Now the total for the first column is 119, and the total for the second column is 2,477. Now let's plug everything into our formula. The sample standard deviation is equal to the square root of the summation of x squared minus the summation of x quantity squared divided by n, and that's divided by n minus 1. Now remember, the summation of x squared is just the total of the first column, so we have this is equal to the square root of 2,477 minus the summation of x squared, which is the total of the first column. The summation of x is the total of the first column, so we have 119 quantity squared now, divided by our sample size, which is 7. And we'll divide that by 7 minus 1. We can simplify the numerator of this radical as 454 divided by 6, and this simplifies to s equals 8.7. So on average, we have a distance of 8.7 away from 17. So our standard deviation is 8.7, which tells me that set B has less spread than set A. Another measure of spread is called variance. Variance, which is simply the standard deviation squared. Now recall S is the sample standard deviation S squared is now going to be our sample variance. Sigma is our population standard deviation. And sigma squared is going to be our population variance. Example, consider the following population: 8, 11, 15, 17, 19. Find the population variance and the population standard deviation. Notice this is for the population, so we'll have to use a different formula. The formula that I'm going to use is sigma equals the square root of the summation of x squared minus the summation of x quantity squared divided by big N, and the whole thing is divided by big N again. Now remember, this is for the population, so we use big N instead of small n. But the process is very similar to before. I will create two columns, x and x squared, and we'll enter our numbers 8, 11, 15, 17, 19, and we'll square these values. 8 squared is 64, 11 squared is 121, 15 squared is 225, 17 squared is 289, 19 squared is 361. We'll find the total of these two columns, and the total for the first column is 70. The total of the second column is 1060. Now we'll plug in the values into the formula. We have the summation of x squared is the second column, 1060. The summation of x is going to be the first column's total, 70. We'll have to square the value and divide by our population size. In this case, we have a population size of 5. I could simplify inside the radical, and this gives us sigma is equal to the square root of 80. Now, what I like to do is calculate the population variance first. Now remember, the population variance is sigma squared. So all I have to do to calculate that is to square both sides, and that's going to give us sigma squared, or the variance, is equal to exactly 80. Now to calculate the standard deviation for the population, we'll just take the square root of 80, and that gives us approximately 8.944. If you were to take the square root of 80 first and get 8.944, then square that value, you don't get exactly 80. So the tip for you is calculate the population variance first by squaring both sides. Then you can take the square root of the 80 to calculate your population variance.